Hello, in this video I'll be showing you how to solve logarithmic equations, which are just equations that have logarithms in. So you might have an x that's inside the argument of a logarithm. For this video it's going to be really useful for you to know the laws of logarithms, so if you don't, I'll link my playlist on exponentials and logarithms below so you can go and watch that. I'll also timestamp the different parts of the video below because I'm going to be working through a few different questions so you can kind of skip through and they get kind of progressively harder as the video goes on. If it is useful, then please do go over to my channel where I have loads of other maths tutorials. Okay, so before we get into the equations, make sure you're familiar with the laws or the rules of logarithms, and I've written those in this red box here. And if you're not familiar with these, maybe you want to go back and watch my previous video where I covered those, because they're really useful when it comes to solving these kinds of equations. So let's start off with the first question, which is sort of the most straightforward. And here we've got log base 2 of x equals 3. And we want to obviously make x the subject to solve it. And the way we can do that is by rewriting this logarithm in an exponential form. Because all this logarithm is saying is, well, what do I raise to the power of 2 to give me an answer of x? Well, the answer is 3, so it's saying 2 cubed is equal to x. And 2 cubed, well, that's just 8. And so we get 8 is equal to x, and we've solved the first equation. Okay, let's now move on to a slightly trickier one. So here we've got a bit more going on. So I've got log base 3 of x plus log base 3 of 9x equals 2. And the first thing I'm going to do is combine the two logarithms together, because I'll notice that they both have the same base and I'm summing them, and so all that means is that I multiply their arguments together. That's the first law of logarithms we looked at, the product rule. So let me rewrite this, and I get log base 3 of 9x squared is equal to 2. And again, to help me get access to the x that's kind of locked inside the argument of this logarithm, I'm going to rewrite it in an exponential form, because this is just saying 3 to the power of 2 equals 9x squared. So let's write that. So I've now got 9x squared is equal to 3 squared. Well, 3 squared is 9, so now I've got 9x squared is equal to 9, and I'm going to divide both sides by 9 and get x squared is equal to 1. Square rooting both sides, I'm going to get x is equal to plus or minus 1. And so the next question is, well, can I accept both of these solutions? And actually I can't, okay? So I've got two solutions. I've either got x is going to equal 1 or x is going to equal negative 1. And if we look back at the original equation we started with, can I calculate log base 3 of negative 1? So let me write that down. Can I calculate log base 3 of negative 1? And let's say that equals a number a. Well, no, the argument of my logarithm can never be negative, because if I rewrote this in exponential form, it would say 3 to the power of a equals negative 1, and there's no power that I can use here, no value of a that's going to take 3 and turn it into a negative number. And if you're unsure on why that is, either revisit my video on logarithms or my video on exponential graphs, because I think that explains it quite well. Okay, so we would reject the solution x equals negative 1 and just use the x equals 1 solution. Okay, so let's look at the third and final question, which is probably the trickiest one. And when looking at this, the first thing I'm going to try and do is combine the arguments of the logarithms on the left hand side. And the reason I'm going to try and do this is because if I can put all of my x's into the same logarithm, then it's going to be a bit easier for me to make x the subject and therefore solve the equation. And so the way I'm going to do that is by first using the power rule to put the coefficient of this logarithm, so 2, up into this power. So let's do that. So we could write it as log base 2 of x squared minus log base 2 of 2x plus 5 equals log base 2 of 4. From here, I'm going to apply the quotient rule because I've got two logarithms with the same base and I'm subtracting them, which means I just divide their arguments and combine them into one logarithm, which is kind of what I wanted to do at the start. So now I've got log base 2 of x squared over 2x plus 5, and that's going to equal log base 2 of 4. Now, from here, there's quite a few different ways you could go about solving this equation. One way might be to look at the right hand side, and you could say, well, this just says, what do I raise to the power of 2 to give me an answer of 4? And you could say, well, that's got to be 2, because 2 squared is 4. And so we could rewrite the equation, like that. And so I could say log base 2 of x squared over 2x plus 5 equals 2. And I could go about solving this. And the way I would do that would be to rewrite it in an exponential form and say, well, 2 squared equals the argument, so I get x squared over 2x plus 5 equals 2 squared, which is 4. Multiply both sides by 2x plus 5 and we get x squared equals 8x plus 20. Let's put all of my terms onto the left hand side and I get x squared minus 8x minus 20 equals 0. Let's then factorize this and I'm going to get x minus 10 and x plus 2, which therefore gives me solutions of x equals 10 and x equals negative 2. I'll come back to this in a second. I just want to show you an alternative way you could have gone from here. So going back to this point, we could say, well, I've got log base 2 of this is equal to log base 2 of 4. Well, therefore, the arguments of these logarithms must be the same thing, which is just going to give me x squared over 2x plus 5 equals 4, which you can see is the same step as here. And finally, if you really wanted to, another way you could go about solving this would be to subtract this log base 2 of 4 from both sides and then apply the quotient rule. But I think that's maybe a bit more effort than you want to have to do. Anyway, so we've solved this now. We've got our two solutions. We've got x equals 10 and x equals negative 2. Let's just go back to the original and check if these solutions are valid. So let's start off with x equals 10. Well, if I substitute x equals 10 into the argument there, that's positive, that's fine. Let's put it into the argument here. Well, I get 2 times 10, which is 20, plus 5, which is 25. So that's all good. So I can accept my solution, x equals 10. How about x equals negative 2? Well, if I put x equals negative 2 into the argument of this logarithm, it becomes negative, which we can't have, and therefore it doesn't work. So I'm going to reject the solution, x equals negative 2, and just have x equals 10. So hopefully this video was useful. If it was, go over to my channel where I have loads of other maths tutorials, and thanks for watching.